concrete. If you like construction. So let's talk about floor slabs today. So this is kind of how I lived my life for a very, very long time. It was 1 square foot at a time, especially for commercial floor slabs. This is the library that we did over in Missouri. So it's right when Oklahoma, Arkansas, and Missouri meet. There's a little town there called Southwest City, Missouri, and so we went and put in a library, helping put that in. And it's very small. It's only about a 4,000 square foot, floor slab. But this is the big deal for that town. I mean, it's very small. And so they had a lot of stuff that was donated. So I think it was about 650,000 was, I think, what kind of the estimate was. But it could be a little bit more. I wouldn't doubt me if it was more like 800,000. But it's kind of hard whenever people just keep donating stuff and they don't really tell you, They just say, here, just take it, just take this, because it meant a lot to this town. And so it's a really beautiful little library. And it's kind of on the lighter side of what you think of as a commercial floor slabs. But I kind of wanted to show some of it, show some of the details. A lot of times whenever you're going out and you do this every day, you don't even think about taking pictures. And, it's not like I had cell phones then that had cameras on them. So you could just go out and take a bunch of pictures. It just wasn't as prevalent. But we did have a lot of decorative concrete stuff. So really there was 2 stages to this project. The first stage, we went and did the floor slab, did the foundation and everything. We came back about 6 months later after they got the actual building done. And then we came back in and did the sidewalks and parking lot and everything. Let's see now. So there are different decorative concrete that we got going on. So whether it's, I think this is like their back patio, this is their front entry. And then instead of doing like little light posts, we actually did, when you go out to like a parking lot or something, you see those round little concrete, they just don't look very pretty. And so we actually my cousin actually did this where he just hand floated all this in and actually stamped it. So it looks like a big boulder, kind of cool. My job was just to take the picture and I kind of sucked at it, but that was, I kind of failed at that, but he did a pretty good job hand floating it in. But whenever we go talk about commercial floor slabs, the goal is like we talked about in the past, is you get to the right elevations. And you want to make sure this pad's really compact, especially when you talk about floor slabs. A lot of times they'll call the word pad because it's nice flat area to put that slab on, a concrete floor on. So for this project, we actually used a spread footing. I'll talk about foundations in a couple lectures, but in essence, they had a typical spread footing where you just dig down into the dirt. And you have a strip footing here, and then you come back and you actually put in a stem wall, short wall. When we originally did this project, we saw the blueprints. They wanted it on a certain way where it was going to cost them a lot of money. So we came back and we worked with the architect, an engineer on the project. Instead of having 12-foot tall walls, we got them down to like 3 to 6 foot, something like that. And it really was a spread footing. This is kind of the design that they had all the way around it. So a lot of times with these spread footings, all your weight is put on the edges of that slab. So all the weight gets transferred through here. And so you have a lot more flexure. So if you think about your moment of inertia, when you start having deeper and deeper beams, you start having less and less flexural strength. You have more flexural strength because of that. So it can really help you. You don't have to just dig out this gigantic, you know, this gigantic footing here and just make it full of concrete. You can come back and take out these parts there, but still get a pretty good moment of inertia from it. So part one, so this is kind of the soil there where there's a bunch of rocks. And so the soils really, you could have went through there and used form work if you wanted to. We didn't. It wasn't really big enough to really save us a bunch of money. But they had, in essence, you have your rebar here. So you just want your rebar off the ground. You don't want any dirt clods in here or anything, and you want it to be, as straight as you can. And so you can see here, there's little rods going down. That's just to hold up the rebar. So there's two, I think they're 5/8 rebar, so number 5. So there's 4 of them going right there. And you can see there's a little bit of an overlap. So usually it's 25 times. You'll go over in your structures 2 class about how to design some of this, but there's an overlap that you have, or spacing lap. And so I think for this was about 2 foot is what we overlapped them, is what the print said. And then you have people coming back here. Your concrete, these 2 people are going to sit there and knock off the basics of just, leveling it down. You're going to have somebody, maybe you may have, like here, you may have a straight edge or a really long board. This is a wooden come along to go and check everything. So usually we have like a laser level to go through and check the top, make sure it's all nice and flat up there. Then you have people come back on the top and actually float it down. So it's not as common to use vibratory equipment on floor or on foundations, but you more than welcome can. It's just not as common. And then after you get everything nice and leveled out, then you come back and you put these pieces of rebar in there to connect your strip footing to that stem wall. And they're spaced at, forget if they're, I think they're every 2 foot, I think 3 foot, something like that. Then it takes a while, but you build those forms. Like you see here, 1 on each side. And then you can go through there and pour all the concrete around there. What's kind of interesting is with it, literally after you do your stem walls, that's actually to pour this floor slab, that's actually your the form. So after you get the stem wall put together, the top of your slab is actually the top of the wall. So you don't have to, it just bumps up right there. So there's no pouring on top of there or anything. You don't have to do that. So it really does save you quite a bit on your even though this is really expensive, you want to use metal forms if you can. Usually renting them is a lot cheaper. We had, I forget how many loads of rock that got brought in after we got done with the forms. So we had to go through there, and really it was kind of a square with one little output for the, I think it was the entryway. And so, A squared plus B squared equals C squared. Hypotenuse, Pythagorean theorem. The basics of making sure everything's nice and square. You do that on a normal basis, trying to make sure that, this is squared. You go and take a tape measure, and you measure, make sure all your lengths are right. And then you take a tape measure from corner to corner. You make sure that this is going to match this, so that it's, so that it's not at an awkward angle. It's not a parallelogram, but it's nice and straight. That kind of makes sense what I'm saying? Very basic 101 form work. So I didn't have a lot of good pictures from this job. It was, I think the bank helped take some of those pictures and said, hey, you're more than welcome to take them, do whatever you want to do with them. This is actually a project we did in Guthrie, outside by the, just north of Guthrie, but this is one of the floor slabs. And so you go in here after you get your forms all set up, you're gonna go and do dirt work. So a lot of times you'll see people with these come-alongs, I like to think of a rake that's metal, that doesn't have any holes in it. And they'll go through there and they'll flatten that top of all the dirt out and compact it. And they'll have a compactor usually come in, check everything. If you're going to have your plumbing or your electrician put anything in there, that's whenever they do it, before you go through and knock off all that dirt. You may have some of the initial stuff done, but you really, if you're going to do house slabs or apartment complexes, they're going to come in and tear some stuff up pretty good. But you want to make sure they have a general idea of where the level is going to be at, so that they don't get things too high or too low. So after you get that dirt leveled, a lot of times you're going to put a vapor barrier down to, a lot of times it's plastic around here, to make sure moisture doesn't go throughout the floor slab. And then on top of that, you're going to start putting your rebar. So you're going to start placing it. So usually, if it's like this, you don't start placing them this way. You always do the longest way first. For a couple different reasons, but mainly it's for a structural purpose. This is your longest part. For the strength wise, they usually want you to start placing it longitudinal, so the longest length. So rebars in 20-foot sections or 30-foot sections normally. Normally you can buy them in 20-foot. So you may start out and do your first 20-foot section. Take a tape measure to measure out exactly where you need to be at. And then you put in your next 20-foot section, you splice it together. So it may be, depending on what your diameter of your bars are, it may be 10 inches or 12-inch spacing where these splices are. So I've talked about this before, but you can see how here there's splices of rebar, how they're overlapped. And you can see how they're much higher overlapped on the actual footing. And you just tie those together. Then you do your last one. You're going to measure, figure out how much you need from the edge. A lot of times you'll be on slabs, you'll be 3 inches from the edge. So you don't want it to be exactly, up to the form. There's always a little bit of what you call a cover. So you want to cover that rebar with concrete. And so you're going to measure your lap plus the amount it takes to get, maybe up to the 3 inch mark up here by the forms. So you may want to measure from the inside of the form all the way to where it laps at, and then minus 3 inches. And you figure out, how many you need. Then you go the other way. And you just start, going on the other side. Then you come in and you tie everything. So this might be what your floor slab looks like after, you did your form work, you had your plumber come in, and then you put your plastic down. So that white is, it's a plastic vapor barrier, and then you have your rebar there. Then you have these little plastic chairs. A lot of times you'll put down to raise that foundation or that rebar up so it's not on the ground. You may have somebody come in and inspect it for city, county. If you're doing state work, you're going to have somebody on the job that's periodically, where you may call them and ask for an inspection before you pour the concrete, whether it's the foundation or the slab, or just depends on what the rules are for their area. A lot of times they'll go out and check the rebar spacing for this and make sure the thickness of the slab is going to look right and stuff. Oop, I forgot to take that slide out. So when we talk about placing concrete, so for that library job I was showing you up in Missouri, so you have your load, how we placed it, we got load one. I think those were 9-yard trucks. Had load one, load two, come back over here, load three, got to load four, and then we started with load five, and we poured this out here. And a lot of times you want to come back up and pour it out over here, but we already had our other truck just sitting there on the other side, so we just poured all that out, jumped over here, poured out 6, so we didn't have to worry about isolation or a cold joint because the concrete was already there. And then we had to do I think it was 3.5 or 4 yard cover order back. That's kind of how we poured it all out that day. So we actually used a wet screed truss. I didn't have a picture on me at the moment. I thought I did. But we used just a wet screed and we screeded everything back. This is a screed truss, which is very, very common when you start dealing with higher tolerance floor slabs, moderate to, moderate amounts. This actually does a pretty good job. When you start getting to Amazon facilities and very, very, very tight tolerance floor slabs, you can't really use these, but you can use these really well if you're doing pavements even. I've done some city streets, and you have a truss, literally a truss that's on top, that's holding that weight together, and you can bend these little pieces of metal. You can actually bend them and twist them, and they'll concave up. So if you want to crown the middle of your city street, that's what they're, you can pop a string line in down over here, and then you can concave it up, and you can actually measure some of that. You can take a laser level, take a GPS, whatever you need to do, and level that out too. So it's kind of a cool little method, and it's pretty accurate for what we're doing. But some of these floor slabs are getting these tolerances are so just stringent that people came out with this thing called a laser level, or the laser screed. And they have these highly straight edge right behind it. Just like we talked about with pavements, they brought that over from the pavement side because they needed nice, smooth roads. And they said, you know what, it works really well over there. Let's go over and use it on slabs. So that's what they're doing. So there's a pump truck pumping the concrete up here. You have these come-alongs, normally a little metal rakes without any holes on them. You're grabbing that concrete, placing it, leveling it, and you have that laser screed coming back behind them and leveling out vibrating the top of that concrete. And then you have that highway straight edge behind there that gets everything nice and flat behind that. So I'm not going to get too much into flat and level floors today, but there are quite a few different things you can do whenever you don't have your flat and level tolerances. So level does a lot more with your formwork and your leveling equipment. So if you think about let's see now. So most people, when you think of something supposed to be nice and flat and level, right? You want all the four corners to be the same level. You don't want them to, you want them to be all nice and perfect. And I can't do that exactly right, but if I put it here on the table, all four of these corners are nice and flat, right? Well, it's the same thing with, we talk about, the level, the L. You want your formwork, all your different corners to be nice and flat. You want your grade to be right. So there's a lot of different little details just with the formwork. And then how things are actually leveled out too. Your GPS or you just kind of eyeballing it with a transit. I mean, how good is your formwork? And then the finishing practices can really play into your flatness level or your flatness. They don't play into your level though. Level is more about grade and how things are there. So when we get into finishing, we're going to have your basic placement window where you have your initial finishing. You may use a bull float, you may use a highway straight edge to get the top of that concrete nice and smooth on top. Get that cream up there, get the paste up there so it's nice and smooth. There's no rocks on top. And then you're going to wait to the initial set. So for troweling, you're going to wait way past the initial set because there's a good waiting period here. And then eventually you're going to put your pan floats on. So these are like little discs. Think about if you go and you're eating pizza and you have these pans underneath that pizza that's metal. Similar idea, but they put it underneath the trowel machine and it makes the floor very, very, very flat. It distributes a lot of the weight around there so that it's not going to indent and dig in. And so it can really save you so that you get a really nice, smooth, flat surface. And then after you run your pans, you might run them once, you might run them twice, depends on what's going on. Usually don't run them 4 or 5 times, you're over troweling the concrete then. And then you take those pans off, and then you're going to start hard troweling. So you may have a combination blade that does both float and trowel on top of that concrete. You may have just where you have finishing blades. A lot of times I always use combo blades. I think they just work the best. And I didn't necessarily need something that had have the hard trowel finish, but you may have one that has combo blades, and then you may have another trowel machine that has just the finishing blades on it to do the very last pass or two. And then eventually your concrete's going to get hard and you can't finish the top of it anymore. So if you want to know about stiffness, this is one of the basics. You put your footprint, maybe not my footprint, but normal people's footprint in there. And so, whenever you need to start using the pan float and start troweling, whenever you pretty much have a very, very small footprint. So for me, I'm always going to have a footprint because I weigh 320 pounds. Other people, maybe if you weigh 180 pounds, you can get away with a 0 footprint or a very, very small one. So again, before initial set, floating, before or after floating, before floating. So you can see you can actually see rock and holes and stuff in there. after you take this magnesium float or bull float, you run past that concrete, it's going to look nice and pretty. So that's what a bull float looks like. It's literally just a bigger hand float. It's on a pipe. Whenever you're going in this direction, you're going to have it tilted up slightly. You don't want it cranked up there like that, because then you're going to create waves of it. You want it tilted up just slightly enough, just high enough to get over the top of that concrete. So you want to keep your finishing equipment as flat as you possibly can and still do the job. That's how you get things really nice and flat when you're finishing concrete. For a highway straight edge, a lot of times with commercial floor slabs that are really tight tolerances, they'll pull the concrete in strips. Then they'll use this highway straight edge right here, and instead of a bull float, to get it all nice and smooth. And it's pretty much, in essence, the same thing. You really can't crank these things up too tall. So if you've ever used one, it takes a little bit if you're used to using a bull float, and you go up to that, but it's not that big of a deal. So after you float it, you're going to come in and trowel it. So that's what it looks like after it's troweled. It's a little bit denser on that surface. You have less voids, stuff like that. And then for hard troweling the top of that concrete, this is a power trowel. Obviously, there's two different trowels underneath. So a lot of times you'll have 4 or 5 blades for on each side. Yeah, 4 blades on each side. A lot of times, and they'll be moved in a pattern, kind of like that. You can see here, there's lights on it if you need it. There's cans on it. All right, so we talk about trowel machine and passes. So however you use your bull float, or your straight edge, whichever direction. If you're going in this direction with it, the bull float straight edge that you got done with, you're going to start in the perpendicular direction. So if you go in this way with your bull float straight edge, you're going to start troweling this way. So if you started up here with your placement, this is where you're going to start finishing at. So if you bull float it this way, you're going to start here. You're going to do passes like this. Then you're going to go and do your second pass. So maybe that was a pan. You used a pan trowel. So then maybe you want to take for your second pass, you're going to take those pans off. And since your last pass was with the trowels, in this direction, you want to start in this direction now. So you take your machine, you start, make a pass there, go like that. And then you may want to do a third pass later. So this is as the concrete's starting to get harder and harder. You may want to do a third pass. And so you always go in the opposite direction of last time. So last time you went like that. So this time you're going to go like that. So it's always in a perpendicular direction. So that's kind of what it looks like after about the third pass. This is what a floor slab at times will look like. So you can see these waves in here. So they had a pass. You can kind of see the different waves, and this is right by the form. So he actually turned around, went back. So, so I should also kind of mention, you need always, you have this middle ground here that doesn't ever get any finishing. So a lot of these passes, you actually have to come back and, go through that middle part. So that's why some of these, don't exactly look perfect, is because you're having to kind of go back over and do that middle part right here. So you always have to kind of move over halfway and get that part, and then your middle machine's, you know, over here again. So you're always kind of moving over a little bit, trying to get everything nice and flat and looking good. So if you hard trial past a certain point, you actually burnt in that floor slab. That's actually what was done here. We had a finisher get carried away and has a bunch of dark black spots running throughout that floor slab. So that's what I get for not being there. Left to said, oh, everything's doing great. Last finish, we're done. And then I left the job, and guess what? You burn it in. So that can cause a lot of durability issues. A lot of cracking on the top of the concrete and stuff. So it really doesn't pay to burn it in like that. A lot of times whenever you're pouring concrete, there may be multiple stages going on. You may have, you know, where they're placing the concrete still. This was actually an order back. But then, you know, you're having a guy come in behind and do the bulk loading, the initial finishing. And then right here, you're having these people go and actually trial that concrete. So there may be all three going at once, depending on how big of a project you have. You may have it where it's all, you know, right there together. So kind of the last part is whenever we talk about a floor slab. So the saw joints. I've seen some blueprints where they have all the saw joints laid out for you exactly how they want it done. They have other ones where there's just some like random note over here in the corner that says every 15 feet or every 10 feet or something, every 20 feet. On the project up in Missouri that we did, I think they were every 10 feet, if I remember right. And so that's kind of what the floor slab looked like after we got done. So this is the top of that stem wall, and they had anchor bolts scattered throughout it. And then we did all of our sawing. So that's kind of the end of that. We've talked about sawing and why you need to saw. This is an early age entry saw, so this is kind of right after the concrete it gets hard. You come back. A lot of times I'll take an 8-penny nail. I'll just kind of scratch the top of the concrete in one little spot. And if it doesn't make any marks, that's usually when I know I can go and actually start sawing that concrete. If it starts making marks, then a lot of times you'll start having this thing called raveling, where it looks like up there where you're finishing it too soon. So you need to be within this finishing window where the concrete's gained enough strength. We don't have raveling. So if you do 2 times whatever the thickness of the slab, so it's 2 times 5, that'd be 10 foot. 2 times 8's every, or 2 times 4's every 8 foot. So stuff like that. For elevated floor slabs, so elevated floor slabs can look a lot of different ways. This is one that we had that had a metal bottom, so you don't have to do dirt work with elevation with elevated slabs, but you have to do a lot of form work. Luckily, this was a metal building. With the metal building guys, they did everything, so we just had to come back in and do a lot of the concrete part for them. So that's kind of nice. I won't talk too much about multi-story floor slabs in here, but typically whenever you're dealing with multi-story floor slabs, you're doing early age concrete or high early strength concrete, which we will talk about some. But in essence, you have every floor. You want to remove that formwork, all that shoring that's holding up all that concrete. So in this is metal. A lot of times you may have wooden or metal formwork that's temporary that you're going to remove. This will actually stay on here. These pictures will the metal that's on there. With formwork that's temporary, like, you know, whether it's wood or concrete, you're going to be removing that. So, you know, the goal is the quicker your construction process of moving the floor slabs up each story, the quicker, you know, you're going to get paid and hit your bonuses. So you're going to try really hard to remove that shoring as soon as possible. So that's why we get into early age strengths, and we'll talk about that a little bit more. Not today. Is there any questions about floor slabs?